Okay, so right now we actually comes to look at the what do you call that, pandas, introduction to pandas. So first we actually run your matplotlib inline from Google import drive, and the content is from Google Drive. So this is basically, as mentioned, I try to put it in the Google Drive where there is able to kind of put that in. So when you run this, hopefully actually goes to the content, and then you connect to your exact Google Drive, which actually has used this, and then continue, and somehow ask you to map to the Google Drive. And basically the drive mount is the content at the G drive, which is your Google Drive. So for Panda series, what we want to do is a 1D array, and it's supported by many data types. So with that, from Google Colab, we import again. You actually can do that one more time. Basically I've just done that, and then so it's mounted at the content drive itself. Then you import pandas as PD, and the object as mentioned, the pd.series 35 minus 5 1, and then you can have object. When you run these codes, it basically gives you like 0 1 2 3, right? 0 is still the starting, and 0 is like 3, 1 is 5, 2 is -5, and 3 is 9, and a data type is an integer 64. So you can run the objects as values, and you run that, the array become 3 5 -5 9. So you see the Pandas series is this series with 3 5 -5 9, and then with the array you can actually do the array index. So object indexing, you can actually index a range which can start from 0. 4 is stop because 0 1 2 3 4, so there is 4, and then step of 1 you increase one by one. The second objective is you have a Panda series 3 5 -5 9, and then you index it as DBAC. So when you run this, it's basically BDAC. You index it, and then beside is actually the series number and this is basically the data type, which is integer 64. So you can still index it, and when you run the index, it becomes DBAC, which is the data type, right? So when you want to try to run the object A, you see, which is DBAC, right? So A is at the 0 1 2, the second column, and then you can say A is actually -5. You run object A equals to 5. So now you want to run object CAD, right? So you run that C9A -5D equals to 3, right? So this is how you actually could run the object, and the data type is integer 64. So with that, NumPy can like operations such as filtering. So we can do like object to which is object greater than 0. So when you run, you actually still have the index, right? Because you run earlier, and only greater than 0 is kind of least down. So D, B, C, A is -5. This is how it's excluded. Data type is still integer 64. So then we can still import NumPy as MP, and MP, which is NumPy exponential of your object number 2, where object number 2 is here, right? Anything that's greater than that. So you actually has an exponential 3. So your exponential of your 3, exponential of 5, exponential of -5 is 0, very negative, and then exponential of 9 actually give you this. So but this one gives you a floating number of 64. Right, so now we can start to code or generate some AI in the series. So in the series as fixed lengths, we order some DIC, which is like a dictionary. So basically you map the index values to the data values itself. So data containing in Python dict, D-I-C-T, you can create a series from pressing the D-I-C-T, which is a dict. So constant can be Bukit Batok, then you have colon 2300 Hougang, given number East Coast Marine Parade. So when you run this, it's basically trying to give you column Bukit Batok is 23,000, Hougang is 25,000, etc. And this is an integer 64, right? So right now we have some constant name as usual, and then you have some Pandas series. Yeah, and then you have a constant and constant name and data. So you can kind of write this down and then you run. So see what's happened is there is a and A, which is a non-applicable data. Jurong doesn't appear on top, so it actually becomes a and A. And then of course West Coast is not inside, so data type become a float 64. So missing data is something we want to do. You actually have a Panda is now is very similar to Excel data names. So you run data name Bukit Batok is false, Hougang is false, Jurong East becomes true because it's now, right? So if it's now, then it becomes false. So false meaning to say it's not now, which is Bukit Batok is has appeared as what we can see earlier here. So now we run Panda not now, right? Not now meaning to say is not not zero. So Bukit Batok becomes true because it's not zero, there is something, and while Jurong, right, is actually false because there is really not inside there. So this is how it's been done, and data type is the Boolean logic. So we can take a look at data frame. Is a 2D table labeled label. It contains an order of column which can be different data type and the stringing or boolean etc. It has rows, column, index can be considered as DIC, which is like a database, and series to be shared in the same index. So now let's take a look. Data, you have your state, column, then you actually had East Coast, East Coast, East Coast, West Coast, West Coast, West Coast, year, you put in the year. So there's 6 data, you actually have 6, and port is the property, for example, is 1.5, 1.7, etc. Then you can actually frame these as pandas dot data frame data. Just now we have already defined PD as pandas, right? Then you can actually frame out. So when you run this frame, you actually has like a frame coming out from here, so we can run a frame from here, right? It convert this data frame into a interactive table. It becomes something like that, which is quite different. Yeah, you can then click back, and then it can actually give you some distribution and graph from the data table itself. So 2D distribution, some time series, so data can so there's some future warning, but some palette is without assigning something, but actually you can actually have this quite different. Yeah, so you can generate the code with frame, or you can view some recommended plot, right? There's some of the plots that can recommend using Panda, so it becomes a little bit easier to kind of look at it. Yeah, so like states versus year, states versus plot. So this can be kind of yeah, you generate some codes with a frame. Of course, you can generate like frame and suggest a plot, and kind of work from there. So yeah, let me just click on this. Yeah, so this is a frame tail. You can still frame this one, and if you click on this, it actually come out with some suggested chart as what we actually done just now. So it can actually pop out like suggested chart, 2D distribution chart, etc. Yeah, right. So now you have another Panda data frame, right, which we want to see, and then we can run this. Then you actually have a year property property. So this become a data frame. So data frame, we can actually still put in data frame column year, state, property, and revenue. Yeah, this is not applicable. Then you can put a frame 2. Just now we put a frame 1, right? Data frame. Frame 2 will actually has also very similar, except it has a revenue, and NAN there's no data on that. So frame 2 columns. Columns can be year, state, property, revenue, and when you run this, the columns could be indexing from the year. So frame 2, year, the state, property, revenue, right? So the data type is object. So the frame 2 columns, we can actually they put it as we can actually run this as an index. So frame 2 states, we can actually run this, and then when you run 1 2 3 4 5 6, right, so it becomes like East Coast, East Coast, East Coast, West Coast, West Coast, West Coast. There's 6 states, and name can be states data type, which is the object. So empty column can also assign with a scalar value. For example, revenue equals to 21. When you run this, just now you can see that there's 1 2 3 4 5 6 year, the states, the property, and then the revenue can be added inside. Yeah, so you can also generate code using this database, where you can generate a frame. Using the data frame, you can suggest a plot. Let's take a look. Can't. Okay. So let's see. Okay, nothing much. Suggest maybe, I don't know. Let's give a try. Histogram. I don't know whether they have. Yeah. Take a look. It's running. It doesn't seem to be running. It's running, but nothing much happened. So we have another value which actually Panda series. You put in 15.6, 18.9, 24, which is the Panda series, and then you index as 2, 4, 6. So it's like 2, 4, 6, right? And then you put in this value, right? And then the rest which doesn't have is A and A, right? Which is not applicable, and this is frame 2. You can put it as revenue as this value, right? You input it in as a Panda series, and then index it, then you put in the numbers. Right, delete some key. So deleting of keys, you can have frame of Easterns, and then frame 2 can be East Coast. So when you run this, frame 2, which is Eastern, right? Yeah, frame 2, which is Eastern, becomes true, and then East Coast becomes true, and West Coast become false. So you can use a frame, open bracket, as Eastern equals to frame 2 state, equal, that means it's true value is East Coast. So this becomes true, this becomes false. Alright, so now we want to delete the frame Eastern. Then when you delete away, it's no longer there. See, there's this additional column. So indexing is you import numpy as MP. From numpy, import and reshape. df, alright, is equals to the data frame, MP, which is numpy, arrange. NumPy provides any array object at arbitrary or homogeneous item. It's a fast mathematical operation over arrays, linear algebra, Fourier transform, random number generation. Yeah, so this is the data. So index East Coast, West Coast, Jurong, Potong Pasir. So East Coast 1 2 3 4, West Coast. So you actually has arrange 16, 1 2 3 4, and then shape is 4 4. Yeah, so 1 2 3 4, 1 2 3 4, column 1 2 3 4. Yeah. Okay. So DF, there's some errors too. I don't understand why. Let's try again. Yeah, let's try to run again. DF is not defined. Actually, I have defined it. Let's try again. I define, then I run this again. Yeah, you define. You need to run the define again. So you define 2, where there's 2, right? So 1, 5, 9, 13, then it basically becomes that. Let's say we define 4. So when you run this, it's actually coming up the 4th column. Yeah. So name is 4, data type is integer 64. And then now you run the define 3 and 1. So column 3 and column 1. Column 3, column 1. We can actually also try to put like 4. Right, yeah, bracket, so that it is a sign. Then when you run, it actually has 4 coming up. Okay, let's see what they have. Some graph. Yeah. Okay, so column 2 basically only 2 rows. Yeah, so first one is column, second one is row. So now you have a location, right? Location West Coast 2 and 3. So 2 and 3 West Coast, right? 5 and 6, 2 and 3. So you actually pointed out that location row 2 and 301. So you actually run and see what it gets. 4 is 11. Yeah, 4 is 11, which is Jurong, right? Yeah, and then 1 is 8. 1 is 8, yeah, which is at the location number 2, right? Row 0, 1, 2, yeah. So then 2, which is 10, yeah. Okay, so it becomes your own data type is integer 64, location 2, 8, 8, 9, 10, 11. Yeah, so Jurong, and then this is how it can be done. You go straight, or you can actually arrange like 301. So let's try to 302, and then you will get additional row. Yeah. So 3 is 1, 2, 3, 0, 1, 2, 3, right? So it becomes 4, 1, 2, 3. Yeah. Then this is how you can run the location just 2. Everything will kind of run. This is a little bit different from how it's been arranged, right? So that's 3 is 1, 0, 1, 2, 3 becomes 11. 0 is actually 1. Yeah. So this is data which is called Roro Factories PD Pandas series, and you actually put it in the days, and then you assign this as Roro Ferries data. So when you run this, basically you will still give you a line 0, 1, 2, 3, 4, right? Harry free of enterprise, Harry free of enterprise 1980s. There's the first row. Then Ferry Lavender 1991, and then MP none, so there's nothing here, so it becomes nothing. And then the 4th row will be Slija Serenade 1990. So we actually can put this. It becomes an object. Data type becomes an object, right? So Harry, free of enterprise, sank moment after leaving a Belgian port in the Zibri on the night of 6 March. So Roro data equals to none. So you actually run this, it actually becomes 0, becomes none. So when it's sync, you can actually put data 0, which is the first line, as equals to none. So let's try and put 1. What do you think it will happen? So Fairy Lavender will probably be equals to none. Yeah. Right. And then so we can actually put this on what do you call that? Fairy Lavender to be excluded. Yeah. So the data type is now. So see which is now, then it's not there. right? 3 of them is not there, 2 of them is there, so it becomes a boolean. So drop na is basically return to the series on the non-null data. So you run this, has 1.2, 5.6, 3.3, there's some data, 1, there's no data, and then this is how it looks like, yeah? And then you clean drop now, basically clean those which without any data. So when is run, you see those without with n is kind of gone, so it's only one row, right? Yeah. So let's try to put this data again. Instead of none, I can put like 1.5, or I can just put in like 2.7, just anyhow put. Then when I run this, the second row is filled with some numbers, and then when you clean the data, you clean, and basically data drop non-applicable, called drop now, then you actually still have this too. Yeah. So drop now for all. Yeah. So if equals to how equals to all, those which is only like all is not there, then it actually becomes. So drop now 4 equals to not applicable. Yeah. And a 4, the fourth column, because not applicable. So I can actually see if I can add a 5, and then yeah, let's see how it goes. Oh, you cannot run this. Let's put in like that. So you index 5. Okay, so let me just take away this, and then you have data 4, 5 equals to, it's still not running. Cell block. Okay, this is axis 1. Oh, because I run this error, so let me take away. It's just only 4. Probably I need to rerun this again. Okay. Then I can then it becomes, then you're able to rerun. Yeah. Now you can fill missing data. We just want to have an I location for 1. So random number 7, 3, and then for 4, and then 1 column. Not applicable is actually 1, 2, 2, 1, 2, 2, and then the rest 4, right? 1, 2, 3, 4. Column 1 for 4 rows, 2 rows, column 2 is not applicable. So we can just try maybe change this to 3. Let me run this. You actually will have 3 rows. Yeah, the rest are random number from 7 to 3. Yeah, so I can put this maybe I don't know, 10. Probably it's too much. Yeah, just put down. Okay, let me try to run this. Okay, now this is back. Let me try to run this again, say 10. Yeah, 0, 10 to 3. Yeah. So fauna, If there's nothing, you just fill with not applicable as 0, so that you actually fill the data. Then basically fill now is basically you fill up the data and you run. Fill now you replace equals to true. Right, you can see that those which is fill up, right, you kind of in place that. Then sequence data is you basically extract the data from somewhere, and then you set the data set multi-variable number instance like area, computer attribute, real number attribute, donation date, etc. So this is like a set of data. Yeah, you apply Panda function check for missing data, right? And then import Pandas as PD, import NumPy as MP, import not matplotlib pylab as a PLT, and then from NumPy import none as ANA, and then subheader user agent. This is a data that is kind of used, so I can use this data. Let's take a look. Yeah, so there's some data here, right? So I'm trying to pull from a URL, and let's take a look at this URL with as a label, right? Yeah, so this is basically some data, right? It's a mess of kind of data. So I actually try to pull the data, then of course you PD read CSV file, second data, which is here. Header is none, so you don't put any header. Then you print the data. The second data, you PD read CSV file label, the name, target date. You can kind of put it in, and then you print the original shape. Right, let's try to run this. Yeah, it's running. So it's trying to pull the data, right, from just now where we see 0, 1, 2, 3, 4 and 0, 1, 2, 3, 4, 5, 6, 7, right? A bunch of data. So it's 0, 0. Let's take a look. Archive, right? The first one is 3030.39. So you look at the codes. A bit slow. 3030.39. So this is the first data. Okay, then you actually pull from there, right? 2564. Yeah, 2564. So we actually then run all the way of the data, and then this is the second row, the 8th row, right? So it just shows some. So let's take a look at the 8th row, right? First row is 1.5005. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay. So this is how it can be kind of data can be pulled. So there's 1,567 row, 590 columns. The original shape of the sequence data shape is rows, column, right? Original shape, the label is these rows, and then there's 3 columns of it. Okay, so then you can check any missing data. Sequence data is now empty, a value of any. They can print is basically like a nap. Then you do this, so which is print the missing number, which is false, which is true, which is not missing. So we can also column with none, and then the sequence data, and then rows is column. Sequence data is now of any data. So now you print with rows. Yeah. So basically taking the data, then you can also do a descriptive of the data. right? Which is the count, mean, standard deviation, first queue, second queue, third queue, where's maximum rows. So basically there's different rows. Yeah. Then it didn't show all, right? So you fill the missing data column, you run this, you fill up any missing data, fill non missing data, non applicable data, and then you get all fill up. Yeah. Drop rows with missing data. So you drop rows, those data, data frame 0, 1, 2, 3, 4, 5, you index, then the rows times 590 columns. Yeah. All the way. Axis is 0. You drop the SICOM data in axis 1. So you drop SICOM data column, and then you print the rest. So those which has a column which is 0, you don't kind of take it, right? Yeah. So you can see that this, then you run this. First row 20, yeah. Okay, this is Seaborn. Import this data, right? I don't know whether we can import this from the data sets iris. Yeah, and then basically we import Seaborn as SNS, so short form. So iris is equals to SNS. You load this iris data, right? And then you can show the head. Okay. Am I too fast? Yeah. So I run the bearing dimension. Oh, sorry, I did not run this yet. Table description. Oh, can't. I need to run the column index first. It's probably too fast. So bearing factory, I try to pull this data from this series. Let's take a look. Right. Data warehouse. Okay. So we actually can pull from here, where you actually has this data you can pull from here, like dimension 604, right? And mm is 4 inches is this. So let's take a look. 600 series 1. Okay, read from here. PD match is plus, skip rows of 3. Let's take a look. 604, 6000, starting from 6000, right? 10, 26, 8, 0.3, 6010, yeah, 0.3, 26, 0.1, 8 is here, 0.35. So you actually try to pull the data. Then you have a table column, you index it. I did run this. Then you table 0 column, it becomes integer 0 to 9, and then you basically can do a describe. Yeah, just now we try to do a describe, right? You describe, then you have your count, how many counts per column, right? And then standard deviation max. Table 0 .to. I should have run this. Describe. Something is wrong. Not sure. Okay, so let's try to run the bearing. Different bearing dimension loads. You actually run this, and then this is selecting the bearing. We can write a small program, enter data for the bearing selection, and the shaft is 720 mm, and the design shaft life is this. Enter the shaft RPM. Shaft underscore RPM is a floating number, and the shaft RPM, so we can actually do that. The design life is a float life. You input the enter design. Let's say I want to enter 720, then your design life will pop out here, right? I want the design life to be 20,000, and then the design life becomes this amount. Yeah, so let's try to run this again. Let's say I want to run 600. Design life maybe 5,000. So it actually has a design life calculated. Yeah, right. So design life in terms of hours. So it's actually trying to pull the data from there. So you calculate the equivalent load, right? So then you have a load radial axis, x, y, z, and v, and then you basically have your PD equals to your load. Then you recalculate. So let's say I want to have a load of 1,005, and you put enter. XL load of 900, and then equivalent load equals to equivalent load, right, equals to V, which is 1 times X, which is 0.56 times the radial load, which is what you enter, radial load in this case 1,005, and then XL load plus your XL load will give you your PD, and then your C required is C is equals to PD design divided by 10 to the power minus 10 to the power 6 with a certain formula, and then you actually can run this. The equivalent load in NI equals to PD, where it's calculated, and then you print C calculated in kilo Newton equals to C required, and then basically this is the formula C required, which is a PD times the design life divided by 10 to the power of 6 close bracket to the power of 0.3333 divided by 10. Yeah. So select bearing from catalog, while 1 equals 0, while C dynamics equals C required, I equals I plus 1, else dynamics equals to OK equals to I, and you print and see whether you can still run this. Yeah, so dynamic bearing is this, where it's calculated, right? Load of dynamic bearings is to our dynamic OK is equals to dynamic bearing of I. So where is below C required. So descriptive statistics, let's run the descriptive statistics. It can be a timestamp, date, and then yeah, date equals to this, seconds equals to how many. So you can from date import to time delta. Delta is equals to time date, this minus certain time date, then you can actually delta. Start is equals to 2011 January July, start plus time delta 12. So time delta 12 can be 2011 January 15 plus 00, which is your time delta is 12, which is like the 12 hours, right? 12 hours. Then you actually can then now minus 2. What will happen? What's the difference? So you minus the time delta of 12, which is like 19 minus 12, right? January 19, right? So it goes back to minus 2 times of delta time of 12, right? Let's try. If you minus 1 time of delta 12, so you minus away 2021 December, so probably about 19 20, 21, 22, 23, probably like 24. So 24 days. Try. Yeah, so okay, let's try 8. It will be like 19 timestamp of 8 days. Let's try 7 days, so it should give you some January 31st. Yeah, correct. Times 1 minus, so you maybe have 5 time delta of 5. Yeah, so minus time delta of 5, which is basically 17 days. Yeah, this is time, the difference of the delta time, right? Time delta of 12. So this is the difference of timing. Handling time zone, you import PTZ, it's a common time zone, Eastern Hawaiian Mountain Time, and UTC. Then you also can have time zone as Singapore. Yeah, standard time zone is 6:55. You operate as timestamp. Yeah, you can have a timestamp, then which time zone. Yeah, and if it's timestamp in Singapore, you plus 8. Yeah, this is minus 5. The timestamp of Moscow is plus 3, and times, so UTC, then you actually runs the UTC value. This UTC variance between time zone conversion, America and New York. So this is between timestamp conversion. Pacific time, Eastern time, UTC, Japan time. We can print out this. So print specific time, because the format of this in the ISO format. So this can be kind of printed at this particular time. March. Yeah, let's try to time zone Pacific Auckland, right? JTC. Yeah. Yeah, so time zone UTC, PST, Pacific time zone is the time zone of US. So US Pacific time will format UTC date time as time zone PST. So your PST is basically your time zone US Pacific and is in the ISO format. So you can actually kind of do that. Yeah. Moving window, you install Yahoo Finance. Basically, let's take a look at data, right? So historical price difference, Yahoo. So there's some daily price of AAPL. Yahoo Finance, which you can import the AAPL, they download AAPL, and then you can run this matplot inline. So you kind of run this and you basically just show it, plot the close price of AAPL. Yeah, so you see 16 or 1927, something like that. So 1927, so it's basically here. 25 moving average days of Apple stock. We import library, matplot, then import animation as animation, import Yahoo Finance as YF, figure as plot figure, then subject data is APL from this range to this range, animate, then open the stock text and read ys equals to bracket, ys equal xs equals to bracket, ys equals to bracket. For line in lines wise, you split the limiters, you append, and then you clear, you plot, and you animate. Okay, so let's try to run this. You import in the library. Doesn't look like there's anything. Okay, this program is taken from towards science, and then the ticket price different, so you can run this 6 completed ticket, yeah, so at different time. Print data tail, yeah, this is like 4, 5, 6, right? Then the ticket time. Let's try to look at this data, right? Yeah, historical price data in Python. Yeah, you can actually kind of code this. It's the same. And you print. Basically, you plot change +1 cumulative plot. Yeah. So you can actually plot out the lines. And then you combine more data frame together, A, B, C, D. Yeah, you can actually draw some chart, but doesn't matter. Random number, data frame with some random number. You can also concatenate frame 1 and data 2, and then you index those, which is so you see A, B is 0, B, right, is 0.004, this is 0.001, this is DF2, right, DF1, B is minus 0.004, B is 0.001, you minus off 0.004, B, right, yeah, 0 DF1, 0 minus 0.004 minus 0.004. You kind of rearrange this. Okay, so we try to open the data sets for this. Let's take a look. If something is not right. Okay, let's try to run. So something is not right. The URL is like not reading. Yeah. But never mind. Yeah. So basically, this is how it works. For Pandas. Yeah.